And so if we take a look, here's where we're headed. We're going to kind of take the next lesson, section 4.7, and we're going to split it into two parts. So it's unlike the last one. It's not going to be here's all the lesson and then here's a work day. We're going to do part of the lesson today, and you should have some time in class to work. And then we'll add the rest of it tomorrow, and you might have some work time then tomorrow as well. So we're going to kind of make it a little bit more manageable. We are talking about, the objective is to be able to use inverse trig functions. Okay? So two things, kind of two main ideas that we'll get into. You actually did this back in geometry, the basics of this. If you remember when you set up a sine, cosine, or tangent problem. Whenever you worked backwards and you were solving for angles, you used inverse trig. If you remember that sine to the -1, cosine to the -1, that was inverse trig. Now, we're going to go further than just that, just solving for angles. But that's the basic idea. Let me kind of relate it to what we've been doing. If you use your unit circle for a second, what if I ask you, what is the sine of 30 degrees? What's the answer? Sine of 30. Or pi over 6 if I used it as radians. What is it? Yeah, 1/2. Okay? That's what we've been doing. That's what we did before break, where we went through and we evaluated a bunch of different trig functions. We did cosecant, all that kind of stuff. Here's where we're headed now. What if I asked you, that? Before I said the sine of 30 equals what? Now I'm asking you, the sine of what equals 1/2? We're just working backwards. We went from here and got that answer. Now, we're working off of this to find the angle that goes with it. Okay? So that's that in the most basic form. That's the general idea of what we're trying to do today. We're going to be trying to find the angle measures that go with the sine, cosine, or tangent. Okay? But there's some restrictions to that. There's some stuff that goes with it. So real quickly, if you take a look at this one, this is just a recall kind of thing. We're talking about inverses. Back in chapter 2, I think it was, we talked about inverses and finding inverses and all that kind of stuff. Real quickly, if I ask you what f at 3 is, what's the answer? Yeah, plug it in, you get 7. Okay? So this is the ordered pair, 3, 7, when you plug that in. If you remember back to inverses, one of the main properties was, if we tried to find an inverse function, you flipped the x and the y. Okay, they had that property where you switched x and y around, and then you'd resolve the equation. Okay, but domain became the range became the domain. Everything flipped, which means even though I don't have the inverse function, what would the inverse at 7 be? Yeah, it's just flipped. Okay, so this would be 3, meaning we have the point 7,3 would be on the inverse function then. Okay, so it's just that concept of flipping domain and range. This is really to remind you of that concept is what's going on. Okay, one other question then. If I give you that f at x equals x squared, anybody tell me what the inverse is at 9? See if this one makes sense. This one's a little bit trickier. What is it? It's 3. It's actually technically it's either 3 or -3. Here's what this is really saying. If I put those together, what I'm really asking you is that. What's the value of x? What's the value of x that when you square it gives you 9? Okay, that's really what's happening here. Okay? And so, if you were to solve that, your answer is 3 or -3. We ended up with 2 possible answers. I bring that up because today when we look at stuff, we want to end up with one answer. And so when we go through and we talk about inverses, we're going to limit some things a little bit so that we don't end up with more than one possible answer. We want to end up with one right answer. Okay? So this is to kind of refresh your memory a little bit about inverses and the idea of getting one right answer versus more than one possible answer. Okay? Now, one other thing we talked about with inverses was the idea of one-to-one functions, okay, which we'll get into. But let's go to the next slide here. If you take a look at like our parent functions here for a second. Domain and range. first question, if we have the sine wave, what's the domain of the sine wave? How far to the right would it go? How far to the left would it go? Yeah, everything, right? It just keeps going. You keep going to the right on the way, and you keep going to the left. If you think about it as the unit circle, you can keep going around the unit circle in either direction forever and ever and ever. So domain is negative infinity to infinity. What's the range of our sine wave? What is it? Nate, you said something.
Amplitude.
It deals with the amplitude, right? Whatever the amplitude is. So on our parent function, minimum of -1, maximum of +1. Everything is sandwiched between on our parent function, between -1 and 1. If that amplitude changes, then the range changes along with it. But that's the basic idea. What about cosine? What's our domain of cosine? All real numbers again. Same for the same exact reason. Negative infinity to infinity. What's the range? -1 to 1 for the same exact reason. Okay, goes up to a maximum of 1, goes down to a minimum of -1. So all of the answers, every answer that's on the unit circle, square root of 3 over 2, 1/2, square root of 2 over 2, all those values are between -1 and 1. Okay, every single one of those. Domain's a little bit harder, but what's the domain of a tangent? Yeah, so kind of. For one wave, it's sandwiched between those -π/2 and π/2. But then it keeps going, right? So it's a little bit harder to define the domain on this one. It's technically all real numbers, except for where the asymptotes are located. Okay? Which you'd have π/2, then you'd have 3π/2, then you'd have 5π/2. So I'm not even going to write that one down only because of the fact that it's a little bit harder to write down and there's not a ton of space. But the idea for tangent is it's all of the waves, it's everything except for those asymptotes. What's the range of our tangent function? That one's a little easier to write down. What is it? Ian? Yeah, -infinity to infinity. That wave will go down forever, it goes up forever, it's got everything in between. So we'd have -infinity to infinity. Here's why I bring this up. Here's why we're talking about it. Because now we're going to get into the inverses of each of these functions, the inverse functions, which means our domain and ranges are now going to start to switch. Okay? So we're only going to plug in values. We're only going to start with values between -1 and 1. And we're going to look at why we have to restrict from -infinity to infinity. It doesn't quite work out. We got to make a restriction on it. Okay? So if you take a look at the next slide. In order to have an inverse that's an inverse function, if you remember back, it's got to pass the horizontal line test, which none of our functions do. Okay? If you look at the sine wave, if that kept going forever and ever, it passes the vertical line test, so it's a function, but it would not pass the horizontal line test, which means the inverse is not a function. In order to work with inverses, they have to be functions. So we're gonna make some restrictions. Okay? Same thing with cosine. It's a function, passes the vertical line test, but it does not pass the horizontal line test, which means the inverse is not a function. So here's what we're going to do. We're going to restrict the domain. Okay? So if you take a look at the graph, and I know on your sheet it didn't copy off real well. Maybe it's because the graph is yellow, but the actual wave didn't copy off real well. Well, like I just said, if I put in a horizontal line, it's not going to pass that. So what we're going to do is restrict it so that it will pass the horizontal line test. We're not going to use the whole wave. We're going to focus in on a part of it. And the part that we're going to take a look at is from right here. From -π/2 to +π/2. We're going to get rid of the rest of this stuff we're only going to focus right here on that middle part between -π/2 and +π/2. Would that part of the graph pass the horizontal line test? It would, right? And that's why we're restricting it. That's why we're doing that. So that now we can actually work with the inverse. Right? So we have a restriction. So if you take a look, here's what that means then. Here's what this is talking about in your notes. So two notation type of things. Number one, remember back to inverse sine. Like I said, you use that in geometry. Inverse sine, inverse cosine, inverse tangent when you're solving for angles. Here's another version. It means the same thing. If you see arc sine or arc cosine or anything with arc in the middle, it means the same, or in the front, it means the same thing. Okay, so two different ways to write the same exact thing. So domain is now -1 to 1, okay, because of our everything flipping. And here's really the key part right here. Range is defined between -π/2 and +π/2 because of our restriction. Okay? The only answers, the only place that we can come up with answers is right in that area right there, between -π/2 and π/2. Which means, if we look at our unit circle or our quadrants then in general, if we're only between -π/2 and +π/2, we start here, going in the positive direction, here's π/2 right here. Or, because it's going the opposite way, because we're dealing negative, here's -π/2 then as well. Okay? Which two quadrants, are we working in? Our answers have to be in, what is it, Triton? 1 or 4. Okay? These are the only two quadrants that you can have your answers in when you're dealing with the inverse sine or the arc sine. And a quick heads up as well in terms of quadrant 4. We're not going all the way around in the positive direction and ending in quadrant 4. We're going in the negative direction. So I can't have like 7π/4 or something like that. It's got to be the negative version going the opposite way based on the way that the range is restricted. Okay? You're either going a little bit in the positive or a little bit to the negative. So let me try to put that together then in terms of what kind of problems you're going to see. And then we'll come back. So take a look at the next problem. Here's the idea. These, by the way, are the exact types of problems you're going to see for the assignment today. Okay? A couple people had asked as you were coming in, whether we'll have work time or whether you'll have a chance to work on some things today. Unlike the last 2 days where those graphs take quite a while to kind of work their way through it and there's a lot of thought that has to go into it, these problems will actually go fairly quickly today. And the assignment should not take you very long, okay, which you'll see once we start getting into stuff. So here's the first part. When I ask you what's the arc sine of -1 over the square root of 2, what I'm actually asking you is, what that actually says, the sine of what angle equals, and let's get this a little bit nicer here. That's not one of the nice values on your unit circle. If I rationalize the denominator, what does that become? Yeah, if we multiply top and bottom by square root of 2, we end up with negative square root of 2 over 2. That's really what I'm asking you. Where does the sine equal negative square root of 2 over 2? That's what the inverse is. You're trying to find the angle now that goes with the values. So if we take a look, let's go to this is where the unit circle comes into play. First part. Here's the first part I want you to do. We just said we had restrictions. We said our answers can only be in quadrants 1 or 4, which means I'm only looking at this part of the unit circle. Okay? Where does the sine equal negative square root of 2 over 2? In quadrants 1 or 4. What value? What angle measure? What is it? Abby, what is it? Okay, yeah, 350. Right here. There's your sine right there of negative square root of 2 over 2, which is at 315. We're going to work in radians, basically, so just a quick heads up that we'll be working with the 7π/4. However, 7π/4 is not the answer. It's what? Because, like I said, we're not going to go in the full positive direction to get there. We're dealing with that angle. We're working on the negative direction. So your answer to this question is theta is -π/4. That's the angle measure. That's the value of sine that would give you a negative square root of 2 over 2 in our restricted domain. Okay. Now a quick heads up, going back to one of the kind of the warm-up things that we talked about. here's why the quadrants matter. Here's why with the restrictions. Technically, doesn't the sine equal negative square root of 2 over 2 there as well? So you know that warm-up problem where I said it could be 3 or negative 3? We got two possible answers. There's two possible answers, but because of our restriction, this one doesn't work. That's our one right answer. That's why I had that problem in there. That's why I was talking about that problem. There is only one right answer based on our restricted domain. Okay? There's the general idea. One thing I think I'm going to have you add to your formula sheet real quickly, by the way. And I'll have you add a couple other things as we go through today as well, is the fact that the inverse sine, whether you want to write it as sine to the negative 1 or arc sine, is restricted to quadrants 1 and 4. You can only have answers in quadrants 1 or 4 when you're working with inverse sine. Okay? So like I said, however you want to write that, whether it's arc sine, whether it's the sine to the negative 1 notation, answers are restricted to quadrants 1 and 4. We'll add cosine and stuff as we move on too, but reason I'm having you add this is going to be your starting point for every problem. You're going to look and say, all right, this one's an inverse sine problem, therefore I'm only looking at quadrants 1 and 4. And then you start answering the question. We talk about an inverse cosine, well, which quadrants is inverse cosine? And then we go from there. Okay? All right, let's keep going. So there's inverse sine. Here's inverse cosine. The concept there is you now have the concept. Now we need to just apply it to other ideas here. So same thing on inverse or on cosine. It does not pass the horizontal line test. So we need to restrict it so that it does pass the horizontal line test. Our restriction is going to be right here from 0 to what? Where should I put the next line? So it passes, if we go to pi and get rid of the rest, that part of the wave will pass the horizontal line test between 0 and pi. Okay? Between 0 and pi is your restriction. Which then, once again, I kind of gave you the rest of it, which means, here's the key part right here. The range for inverse cosine is restricted between 0 and pi because of our one-to-one function. Which means, which quadrants is the inverse cosine have to be in? Somebody say it. Was that you, Cooper? What'd you say? Yeah. Here's 0 to pi. You are restricted to quadrants 1 and 2. Okay, for inverse cosine. Even though there might be answers outside of quadrants 1 or 2, the only answers you're allowed to have are quadrant 1 and 2 answers. Okay. Once again, you can add that to your formula sheet too. Inverse cosine is restricted to quadrants 1 and 2. Inverse cosine restricted to only quadrants 1 or 2. All right, so again, let's take a look at a couple of examples. Once again, here's what example 2 is actually asking you. When I say what's the arc cosine of square root of 3 over 2, I'm asking you what's the inverse cosine, which means the problem really says the cosine of what angle equals square root of 3 over 2. That's what I'm asking. What's the angle measure? So once again, we go to our unit circle. Keeping in mind our restriction, since we're talking about inverse cosine, answer has to come from quadrants 1 or 2. That's the restriction. Where does the cosine equal the square root of 3 over 2? Where's it? Yep, here it is right here. X coordinate, since it's cosine, it's in quadrant 1. There's your answer, pi over 6. Okay. Now, again, there is a second answer. Here's a positive square root of 3 over 2 as well at 330 degrees, but it's not in quadrants 1 or 2, so that one, we throw that one out because it's not in our restricted domain. How about the next one? Let's take a look at the next one. Now here's the other notation. Inverse cosine means the same thing, okay? What I'm actually asking you is, the cosine of what angle equals -1/2 in the first or second quadrant because it's cosine. And if we take a look, where does the cosine equal -1/2 in quadrants 1 or 2? What value in terms of radians? What do we think? Find it on your unit circle. Come on. Where's the cosine equal -1/2? There we go. Thank you, Steve. There it is right here. All you're doing is looking at all your x coordinates. The first one that is -1/2 is your answer. It is at 2 pi over 3. Okay? It is at 2 pi over 3 in that one. Try the next one. On your own, see what you get. Where does the arc cosine equal? What's the arc cosine of 0? See what you come up with. If you're ready to answer, I'm going to call on somebody. Because I get sick of asking and everybody just looking at me. So I'm going to call on somebody random. So be ready with an answer. I wouldn't if I didn't have to. But it's looking like I'm having to.
I always have one pass for the day, and I used it. It's done now.
It's over. All right, Cal, help me out. What's my answer? What's the arc cosine of 0?
Pi over 2.
Okay, yeah, if you take a look, here it is. Got it. Again, you're looking for the cosine values. Where's the first one that equals 0 that's in the first or second quadrant? There it is. Answer is pi over 2. Okay, that's what you should end up with.
Yes.
Let me stop for a second. Making some sense, hopefully? Like I said, the only difference, realistically, is now we're finding the angles that go with our values. We're working backwards for the most part. Okay? All right, let's add in tangent. Last one. Once again, here's your tangent graph with a bunch of different periods. If we put in a horizontal line, there's why it doesn't pass the horizontal line test, because it'll go through all those different tangent waves. This one's a little bit easier, because when we restrict this one, the parent function's already restricted for us. We're just going to use the one right here and get rid of the rest of it. Between -pi over 2 and positive pi over 2, which means arctangent or inverse tangent has the exact same restrictions as inverse sine. Okay? Arctangent and arcsine have the same exact restrictions. So when we talk about which quadrants, there it is again. We're back to quadrants 1 and 4. All right, try the ones on the next page here. Try these 2 problems, or next slide. See if you can get those 2. And again, I'll call on somebody. I'll give you a couple of minutes here to see if you can figure it out. Arctangent of -1 and arctangent of 0. Where is the tangent equal -1? In our restricted domain. Where does the tangent equal 0? In our restricted domain. All right, let's see. Are we ready? Let's see what we came up with. Trent, help me out. What's the first one? What's the arctangent of -1? Okay, let's see if you're right. -pi/4 is what Trent said. If we take a look at our unit circle, again, we are restricted to quadrant 1 and 4. We're trying to figure out where does the tangent equal -1. Now, I don't have the tangents on here. You do. Okay, you have them handwritten on your unit circle. But remember, tangent is sine over cosine. So wherever the sine and cosine are the same, but opposite signs, is exactly where you end up. And sure enough, it is. There's your answer right there. It is a -pi/4. Okay? The arctangent of -1 is located at -pi/4. That's the angle. How about arctangent is 0? George, help me out. What do you got?
0.
Arctangent is 0. We take a look. Back to our unit circle. Sine divided by cosine. 0 divided by 1. Sure enough. There it is right there. It is 0 degrees, 0 radians. Okay? Oops. So we end up with 0. Let me stop just for a second. Any questions? Anything not making sense? I have one extra slide that I ended up adding only because after I had made copies. So you might have to add it to the back page or something. But it's just real quick. It's about the reciprocal functions. So here's the last question that I have for you. What about the reciprocal inverse functions? What about like the arc cosecant? We haven't talked about that. What about the arc or inverse secant or something like that? The first two will be really quick. The third one will take, I've got 3, talking about the 3 different functions. The first 2 will be very quick though. If I'm asking you what's the arc cosecant of 2, here's what I'm really asking you. I'm asking you for the arc sine of what? 1/2. Remember, it's just the reciprocal. So if I'm asking you for the arc cosecant of 2, I'm really asking you for the arc sine of 1/2. And now you're right back to doing what you were doing before. The sine of what angle equals 1/2? Thinking about your restrictions on domain and range and trying to find it just like we were talking about. Okay? How about this one? This one, by the way, if you actually did it, anybody tell me what the answer is? Where does the sine equal 1/2? Pi/6. Yeah. So the arc cosecant of 2 is the same thing as the arc sine of 1/2, which is pi/6. Okay. In this case, inverse secant of -2, same exact idea. What I'm really asking you is, what's the inverse cosine of the reciprocal? -1/2. Which, by the way, is what? Where's the cosine equal -1/2? 2pi/3. Yep. 2pi/3. So those two, like I said, if you just recognize that you're really just asking inverse sine or inverse cosine problems, it's the same idea as what you were doing. The one that's a little bit different, and it's not a lot different, is this one, inverse cotangent. And I'll tell you why it's different. Okay? You would think it's the reciprocal of inverse tangent, but there is a different domain restriction. If you take a look, well, let me go back to this for a second. It is the inverse tangent, but there, like I said, the restriction, you're really saying what's the inverse tangent of the reciprocal, which is still -1, okay, and that doesn't change. But because we're dealing with cotangent, if you look at the graph just for a second, and I was going to restrict the domain, we said tangent was between -pi/2 and pi/2, because of that's where the asymptotes are. Cotangent is from 0, remember, to pi. So your restriction on cotangent is not the same restriction as it is tangent. Okay? The cotangent restriction has to be between 0 and pi. That's, by the way, that's probably the 4th one you want to add to your formula sheet. That cotangent is restricted to quadrants 1 or 2 in this case, because that's where the asymptotes are located. Which means, by the way, let's answer the question real quick. Where in the first two quadrants, quadrants 1 or 2, does the tangent equal -1? What's the answer to this one? It's 3 pi over 4. Yep. So just kind of a, like I said, just a quick heads up that cotangent and tangent do not have the same restrictions. All the other ones do. Cosecant and sine, same restriction. Secant and cosine, same restrictions. Okay? Cotangent and tangent, because of the different asymptotes, different restrictions. Okay? All right. That's the idea for today. We'll build off of it tomorrow with some extra stuff. But that's the idea for today. What I have for you, I've got one worksheet that I'm going to use between today and tomorrow as 2 different assignments. I'm going to have you only do the first part of it. There's 38 questions on it. You're only going to do 18 of these types of problems. They're going to be really quick. You've got about 15 minutes left in class, and I would be willing to bet if this is making sense, you'll probably finish that in the 15 minutes and not have anything else to do. Okay? So, let me give you the worksheet. Answers are on the back of the worksheet, by the way, so you can check really easily. And the rest of the time then is for you to work and ask questions if you have them.